All right, everybody, a warm welcome to the semifinals where we're going to celebrate and deep dive into the challenge as well as the solutions and perspectives today, addressing the NITI Aayog and Atoll Innovation Mission Water Challenge in Next Generation Water Action 2022. Warm welcome to participating students, to the supervising professors, to the jury representatives and others listening in, and not at least our representatives from NITI Aayog and Atoll Innovation Mission and our Indian partners who are representing the water challenge that's going to provide the framework today. We are live streaming from here at the Technical University of Denmark at DTU Skylab, the hub for innovation and entrepreneurship. My name is Marie, and I'm the project manager of Next Generation Water Action, and I'm extremely excited also to see what has been the result and the outcome of a journey that started a few months back. Today's purpose is to give all the student teams that have been working on this challenge in particular to a platform to showcase their solutions and ideas to a jury, but also to the challenge owners, but also to inspire the other teams that have been working with the same onset, the defined water challenge from the beginning. It's an opportunity to pitch and present their ideas and perspectives that we know is also going to reflect their diversity in culture and academic backgrounds and nationalities, and we very much look forward to a complementary journey starting now. On the next slide, I will just briefly go through the program. So we're going to have a session that's a bit more than 1 hour now, where we're going to have a joint welcome. I'm going to introduce a little bit around the journey that started in February and where we are in that process now. We're also going to welcome our partner just to say a few words in the beginning and then do a final reflection after the pitching session around the solutions and the perspectives that has been presented today. But the core of today's session is to give the stage for the 4 student teams that are going to present and share the ideas and perspectives in a video, in a 30 seconds live pitch, and then there's going to be the open opportunity for the jury to also ask questions and clarify some perspectives on both the blog post and the video presented today. We will afterwards conclude with an open networking session, so we very much encourage you to stay tuned online to maybe join one of the student teams in a breakout session to give them further feedback or connect with some of the students in this format that is going to be unfacilitated from our side. The next slide will show a little bit where we started and what has been the framework for the Next Generation Water Action, which has been onboarding 5 partners from the beginning of February that together with us have designed and detailed the water challenges that then has been worked on and addressed by a total of 22 student teams that comes from Denmark, India, Korea, and Mexico. And Kenya, and this is a way where we also try to bring different perspectives and different knowledge and experience to the case owners that are presenting the challenge, but also inspiring the students on what are addressing current water challenges that are relevant for them also to look into how they can bring their academic disciplines on board. If we go to the next slide, then here we're going to see, just 1 second, exactly. So this was the journey from the beginning. Today marks the final milestone before the multi-hub finals that takes place in 6 days here in DTU Skylab, alongside 4 other different locations in the countries that we're collaborating with. The journey has both been taken part on a national level together with universities and mentors and supervisors, but through the Next Generation Water Action Initiative, we have also provided a number of virtual boot camps, one-to-one sessions with the teams. We have brought forward a number of our partners to also share their knowledge and the framework to inspire the students on how to come from a challenge to the ideas and perspectives they have today. The next slide shows a few glimpses of how the journey has been along the way. So again, this has very much been carried by our partners that has also organized national events and activities and boot camps as well. We've had a very valuable collaboration with IWA young water professionals in each of the countries that has also brought forward their network within the water sector and water industry to provide necessary sparing to the journey along the way. You might also see a glimpse here of a picture that was taken here in Skylab a few weeks back, where we had the honor of having Dr. Penan Chinamse here at DTU Skylab to provide sparing to the Danish student team, but is also one that is a core partner in the process here. So this has also been extremely nice that we can also, in a physical way, connect some of the mentors and partners in this initiative. Yeah, if we go to the next slide. So this is also very much a process and initiative that's enabled through our key partners, not only from a resource point of view, but also the partners that are bringing on board water mentors to support and qualify the projects of the students. We also have a number of partners right now, among them our university alliances and our Danish embassies that are preparing for the events that will take place next Thursday, so the multi-hub finals that are going to take place physically. And there is a lot of preparation and work going on there, so you also have a really exciting opportunity to look forward to there. Behind the stage, and also sometimes appearing very much in the emails and the messages, if we go to the next slide, we have an overview of the project team here from DTU Skylab, and also a joint collaboration with the Young Water Professionals, the Danish chapter here in Denmark. Our contact information is also available online, so if any of you have any feedback along the way, but also would like to connect for further opportunities, please feel free to reach out to us. We are here to help, but also co-design and co-create this journey all together. But as the next slide illustrates, the starting point of this has also been that we have, together with our strategic international partners, been able to structure and to define a direction of the journey that we wanted to provide you, the students, the teams that are joining here today. So we're extremely happy to have developed a water challenge and mobilized mentors through your partnership, especially through NITI Aayog and Atal Innovation Mission of this particular semifinals that we're doing now. And before I will give the stage to our challenge partner to just give a few welcoming words before we kick off, I want to check that we are all able to activate our virtual applause skills here on the Whereby platform. So if all of you go and click on the chat function, then there you should be able to send an emoji out into this event. And I would love for all of you to send some good vibes and emojis along the way now, and help me welcome on the stage, just for a very brief welcome, Dr. Penan from IIT Bombay, that has been a strategic partner and also very knowledgeable mentor representing the Water Challenge. So please welcome Dr. Penan on stage to welcome all of you. And Penan, I hope that you are with us. I can see you are still muted. You need to actively unmute to be able to say something into the event here. All right, there seems to be a small technical challenge from Penan's side. We'll wait a few seconds to see if he's joining. Otherwise, we will start kicking off the pitching session and hope that he will join actively also there, and not at least give some reflective words in the end. We are extremely happy that this today is also not marking the end of the process. This is just an important milestone going towards the finals next week, where all of you are invited in different ways. So I hope that now maybe Björkman will take over and guide us through the pitching session, and then we'll in parallel make sure that Pinan is with us for a final remark in the end of the semi-final session.
Thank you, Mary. And welcome everyone to this event. I'm very excited to see what the student groups have put together. We are now I'm gonna introduce the jury and the structure of the pitching before initiating. And for the jury panel, there are two representatives of the challenge, where we have Pradeep, who is representing the National Jal Jeevan Mission, and we have Dr. Panan, who is representing NITI Aayog and is an assistant professor at IIT Bombay. And then as a representative of the young water professional, we have NITI, who is also a researcher and so comes with a strong academic background as well. And then for an innovation perspective, we have our in-house Linda Weiss, who is a sustainability project manager and was actually part of creating and designing the Next Generation program at its beginning. And then we have an academic representation from DTU Sustain, professor and head of outreach, Peter Steen Mikkelsen. These will be our jury members today. And jury members, please note that when we are doing the questions and answers, you can use an raise your hand emoji if you have a question for the student groups. And remember to fill in your scoring sheets and send them to me after the event. We're going to have 5 pitch sessions in the order you can see right now. We will start with Team India 1, and then we will have Team South Korea, and then Team India 2, Team Denmark, and then finally Team India 3. Each session will include a video pitch, which I will play, and the video pitches are a maximum of 4 minutes. Follow the video pitch, there will be time for a live pitch of a maximum 30 seconds. There is no countdown visible in the streaming service, so if you need to keep an eye on your time, we suggest you use your phone or a clock, and we will also be monitoring the time and giving you a signal when it's up. Then there is dedicated 4 minutes for questions and answers, and of course, we're going to end each session with a big applause. And the evaluation criteria for the pitches are 6 different ones. The first one is novelty, as we are looking for innovative solutions. But we're not only looking at novelty in the technical aspect, or it can be novelty in very many different ways in how the business idea is put together, or how different ideas, already existing ideas, are being combined. Then we'll also be looking at the future potential of the solution. And we're also going to be looking at the sustainable impact. And the juries have also reviewed your blog posts. So your blogs and pitches are a part of the assessment. Then your questions and answer performance, Q&A performance, is going to be evaluated as well. And lastly, we're going to check for acceleration potential. And there will be selected 2 national finalists for the from the semifinals for the finals from each country. So the scoring today will help with that. And then there will also be chosen the winner of the acceleration scholarship. But the acceleration scholarship winner is going to be announced at the finals together with the finals award, which will be a scholarship and invitation to go to the International Water Association's World Water Congress here in Copenhagen in September. And then please note that it is also possible for anyone viewing to award acceleration time. And you do this by clicking on the link underneath the video. And this is a great opportunity for you to provide some mentoring or feedback to the students afterwards. And now for the first pitches, I'm just gonna get ready to share the video. And as I said, we're gonna start with Team India 1. And in Team India 1, we have 4 members: Matisvaran, Versaini, Tahanlakshmi, and Darshini. And I'm gonna just apologize for my pronunciations of names, both now and throughout this whole program. But I feel like I have a green card for bad pronunciations, since I myself have a very hard to pronounce name. But team members, please be prepared to give the live pitch after I've played the video. And now I'm just gonna get the video started. Sorry about that. I've been told there's no sound, so let's try again. Okay, let's.
Hello everyone. I observe Mr. Shager and Mr. Prabhu works hard twice a week to remove water hyacinth. Wow, hyacinth has also been removed using robotic JCBs and weed harvesters. OMG. This weed has grown enormously. I don't know how they gonna handle it without the automation method due to low riverbed level.
Are you all right now?
Nope. These hyacinths have grown massively and densely packed. It's difficult to get rid of it.
It appears to be a serious difficulty to solve, so I guess I'll have a brainstorming session with my buddies to come up with a solution.
Hey everyone, could you please tell me your thoughts on the water hyacinth's concerns in the water cycle?
Hey, I knew this water weed grew rapidly and absorbs 35% of the water from bodies of water faster than evaporation. This results in water scarcity, which is difficult to mitigate due to the massive increase.
Yes, it has numerous advantages, such as absorbing metals, but it disrupts the aquatic ecosystem cycle. It also stops the flow of water, produces a stag, and gives rise to the Culex mosquito.
In this instance, we should focus on the eradication, disposal, and reuse of this weed.
I believe I have a plan in mind. We need to consult with an expert before coming to a conclusion. Now, let's get into the field and locate customers with the essential permissions while also working on a solution.
Hello, sir. It's great to finally meet you. I hope you got the gist of our situation over the phone. Could you please explain how to begin?
Yes, that is an excellent problem statement. You must obtain approval from numerous departments in this municipal corporation to engage in the government body, beginning with the sanitary, engineering, and PWD departments for water reuse of hyacinth. You must first obtain clearance for your product testing from the zonal officer and regional commissioner. This procedure might lead to a real-life execution. Best wishes.
It's now time for solution. Here is our barcode prototype. The ease of transportability can be seen here. It uses a conveyor belt to pick up the water hyacinth and crushes it to lower its weight. Logistics costs are reduced by 50%. After seeing our solution, Mr. Sikara was happy, but that doesn't reflect it on Prabhu's face. For satisfying Mr. Prabhu, we can him a business deal on supply of hyacinth to make byproducts. The reductance of 50% logistics and reuse of hyacinth made him happy. Here's our market analysis, which includes a few recent developments in South India, as well as a study that reveals how much money is spent on this specific problem statement. The revenue earned via various channels is shown in the cost structure, together with a return on investment through our monthly target. Finally, based on our market data, we can state that we are focusing on the 55% of money spent on this issue, specifically removal and disposal.
Here's our real-life journey with AIMICDK, NITI Aayog and Next Generation Water Action, 2022, for development of our prototype.
Thank you very much, guys, and ready for the live pitch whenever you are.
Is my voice audible? Guys, is my voice audible?
Yes, it is.
Okay, I'll start. Our team is all about business with blinders on. We all had a common goal to develop a solution, and we made sure that nothing distracted us from achieving our aims. Effective teamwork didn't just happen. It took a good problem-solving skills and decision-making, communication, and interpersonal skills. Deadlines made it difficult yet excited to work as a team. At times, we had lost our minds trying to make our idea possible in field, but after a brief pause, we were track on mitigating our mistakes. Such a team can only win when everyone associated with concentrates on a specific achievement. And we wish the result and the teamwork to be awarded as a promising student startup.
Thank you very much. That was on time. And now for the jury, you can ask questions and you can raise your hands with the emoji function. But maybe Peter is already ready to say something.
Yes, I am, and I haven't found the right button yet. Thank you very much. A very nice and interesting video and pitch. If I understand it correctly, you've kind of invented a system that can extract and crush this material from the vegetation that you harvest. So what?
Actually,
no, sorry.
These plants are not just harvested; they are facing a huge problem for removing it. Because so many crores has been spent, and this particular plant weed has been blocking so much of canals in our places in India. Moreover, in many places also in many drinking water like dams and many places, this particular weed is being harvesting over there, and they are trying to remove it in low seabed level areas. They can't able to clear it, so that's why we tend to develop it.
Yes, and that's very well explained also in the video. My question is, what will you use the material for? How will you ensure that this material that is extracted is somehow made useful for whatever purpose in society? Have you some thoughts on that?
We have from this water hyacinth product alone, we have developed various types of. First, we have indicated with paper. We have developed paper products, paper bags, and handwritten papers, and also we are trying to make fiber from it.
Okay, thank you.
Thank you, Peter. And I can see that Niti has raised her hand.
Hello everyone. I hope I'm audible. Excellent pitch, Madesh, and many congratulations on the good work. I had a query about the capacity or the potential of the belt material you're using, and given that you'd be dealing with large scale of hyacinth, what would be the capacity or per run potential of the machine, if you can share that?
Okay, actually for now, for conveyor belt material, we are using canvas material for now. And since we had a low budget, that's why we opted for canvas material. We are using for a netted aluminum which is used for a conveyor belt for that. So it is quite, while compared to the revenue generated from this market, we could use that particular product for that. Since we got very less amount for the POC, we were using for that. And the thing the timeline for the collection process. So while compared to the existing material weed harvesting equipments, definitely it takes a bit hell lot of time, but weed harvesting equipments cannot go in low level seabeds. In India or many places, we have low level seabeds of 2 to 3 feet because weed harvesters quite huge. They need a cochlean or any other JCPs to carry that weed harvesters. The transportation of that is quite high. So what we are doing is we want to develop like an hand tractor that any human it can be easily monitored and we can make it easily.
Thank you.
So while compared to that, it takes around 50% of the extra time to complete the task.
Okay, thanks for your answer.
Thank you.
Thank you. And the 4 minutes are about to be up. And I just want to remind everyone that there is the open networking session at the end where there will be breakout rooms for each of the teams, and jury members and other guests can jump in between and give additional feedback and ask more questions. Thank you very much, guys. I'm gonna move on to the next video, and the next pitch is with Team Korea with Ji Young, Ji Hwan, Min Koyoung, and Ha Newell. Again, sorry for the pronunciations.
A hedge-less river, Yamuna. This river is sacred in India and is called the River of God. People enjoy the festival by bathing in this river and pray for well-being. But can you see that white foam around the praying person? This mysterious white substance is toxic foam. The Yamuna River, which serves as the main source of water in Delhi, rather affects people to suffer from waterborne diseases. Most contaminants in River Yamuna exceed the drinking water standards. What would be the sustainable and eco-friendly way to supply safe and clean water to people near the polluted river? Delhi has an abundance and variety of environmental assets in the form of the River Yamuna, the Aravalli Ridge, water bodies, forests, and so on. To preserve and utilize these assets, a mix of strategies such as the Master Plan for Delhi 2041 are being prepared by institutions, including Delhi Development Authority, DDA. Since a constructed wetland is a natural pollutant treatment system, it requires little electrical energy and less maintenance cost. Accordingly, it can be said that this solution, which not only plays the role of a water purification system, but also can actively utilize abandoned wetlands, is most suitable for Delhi. Our technology is focused on maximizing the potential of wetlands. We propose a step-by-step method. Each area purifies different materials using plants, so that concentrated purification can be done and results in cleaner water. Water, which is primarily filtered out of large garbage at the entrance by reeds and wire fences, moves to Zone 1. In this area, phosphates and nitrates are the target of concentration removal. In Zone 2, water undergoes heavy metal removal steps such as lead, copper, and cadmium. However, since heavy metal removal using only aquatic plants takes a long time, a method capable of shortening it is required. Water hyacinth is an excellent water purification plant known for its excellent absorption capacity of heavy metals. But at the same time, it has a nickname called wicked weed because of the environmental damage caused by its overbreeding. We suggest a heavy metal absorption stick based on water hyacinth called wick. This can easily absorb heavy metals while suppressing reproduction. This amazing stick is super easy to manage as it changes color when the limit of capacity is reached. Through our sustainable and eco-friendly solution, India can benefit economically, environmentally, and socially. Constructed wetlands using WIC are much more economical than building or maintaining the wastewater treatment plant. As the number of artificial wetlands increases, the Yamuna River is rejuvenated. Moreover, new jobs related to the process of making WIC will contribute to job promotion in Delhi. Ultimately, wetlands provide clean water to 10,666 households and keep them safe from waterborne diseases. This will bring us closer to the UN Sustainable Development Goals number 6, ensuring access to clean water and sanitation facilities. Make changes with WIC.
Okay, girls, you can start your live pitch whenever you feel ready.
Hello, we're Team WIC. We propose a constructed wetland using adsorbent called WIC. This is the most suitable solution for India in view of utilizing Delhi's abundant green asset and water hyacinth, the wicked weed. By removing various substances, including heavy metals, the Yamuna River restores rejuvenation, enabling a sustainable and safe supply of fresh water. Make changes with WIC. Thank you.
That was very short and on time. Thank you very much, girls. So now to the questions from the panel. And I see that there is already a hand up. So just go ahead.
Hi, I'm Dr. Divya John. I'm doing this Pradeep Singh from National Union. So, my question was for me. So, what is our disposal method for these sticks?
See, but I can hear you. May I ask you again?
Sorry, I think the question was, what is the disposal method for the... I didn't hear actually what. For the sticks, I think.
You mean the specific way to absorb the heavy metals with WIC?
I can help with the question. I think she meant what was the disposal method for the WIC?
Disposable. First of all, WIC absorbs some heavy metals, including lead, copper, cadmium, iron, and phosphorus. So it has a great ability to absorb some fatal substances that affect human health, and it can be easily changed because it is produced as a portable size. And also, when it comes to a full limit of its capacity, it turns to a dark red or light red. So it is easily to notice when the workers need to change it. So yeah, this is our answer.
So after using that one, after getting it red, so what you are going to do with that? Is there any regeneration process for those wick or what?
Maybe I can repeat again. So what will you do with the wick after it has absorbed the material? What will, how will you dispose of them?
Since it has accumulated a fatal substances, as I said, heavy metals, so it cannot be used twice. I mean, it cannot be recycled. So it will be dumped as a waste. like other kind of garbages, but we are going to have more researches about using this wick one more time to use as a fuel or something else. Yeah.
Thank you. And then I think we have time for one more question. I think Peter, he had his hand up.
Thank you very much. Thank you for a nice video and pitch. My question is related to how you ensure that the water with the contamination gets in contact with the wick filter. The way I understand your system, the wick is a stick that you put into like a water basin. So how do you ensure that the water does not just bypass the wick and go directly to the outlet while still being contaminated? How do you ensure this contact?
We actually did an experiment of non-living hyacinth by drying with a oven and put it under the surface of the water, and we figure out it has enough capacity and ability to absorb the heavy metals. So I'm sure, and I believe that it will absorb the heavy metals without just passing the wick.
Thank you.
Thank you. That was all the time we have for questions. Thank you very much. And we're now moving on to the Team India 2 with Shubham and Mariswaran. And I'll be starting the video.
Hi everyone. In India, millions of people travel or commute on an average in a year. And in order to quench their thirst during traveling or commuting, they either drink directly from water taps or buy a packaged water bottle, which is the only solution present in the market. And because of this, they either get sick with waterborne diseases from contaminated taps or develop heavy money burden on them by buying packaged drinking water bottle on the long run. And the byproduct from this is plastic pollution, which is created in our environment, which is a big concern nowadays. So by seeing this problem in the market, we thought of building and designing a bottle which can directly filter water from tap source while commuting or traveling. And thus we designed a bottle which can filter water directly from tap source through its 4-layer filtration system, which actually removes suspended particles up to 0.1 micron size, residual free chlorine, as also reduces the TDS of water, as well as eliminates the bacteria that are present in the water, and help us to save money on drinking water expense. And to bring our idea into reality, we started building our initial prototype of separated filter layers, where our first layer was sedimentary layer, the second layer was ultrafiltration layer or UF layer, the third layer was activated carbon, the fourth layer was UV, that is ultraviolet filter layer. We have also built our filtration setup where feed water is provided through booster pump, which maintains the pressure at 5 psi and flow rate at 1 liter per minute as per normal tap conditions. The process of filtration is the sample water is passed through sedimentary layer, and then it's again filtered with ultrafiltration layer, and later the filtered water is again passed through activated carbon layer, and at last it is treated with the ultraviolet filter layer. And through our filter layers, we were able to reduce the turbidity from 5.3 NTU to 0.3 NTU and reduce the TDS from 746 ppm to 473 ppm, and also reduce the residual free chlorine from 1.73 milligrams per liter to 1.16 milligrams per liter. And we also found that activated carbon block filter shows better results than activated carbon granules one. Later, The three filter layer, that is sedimentary filter, ultrafiltration and activated carbon layer, will be combined in a single filtration system which will be connected to the inlet cap of a bottle and will be seen as a compact bottle as our final product. And after this, we plan to work on removing dissolved heavy metal or mineral ions that is present in the water through ion exchange method to provide a complete filter solution in the bottle for individual. But as of now, our solution gives a final stage filtration for people while commuting or traveling where heavy metal or mineral ions are removed previously. In our team, we have two innovators and two mentors to work on this idea. Product is new, innovative in the market and patentable. Our next step is to complete our experiment and apply for patent. We plan to serve underserved section of the society to get access to drinking water while on go. So if you are interested in what we are doing, feel free to reach us and any help will be really appreciated.
Very nice. And fire away with the live pitch when you're ready.
Yeah, so hi everyone. So with multidisciplinary team and water experts from ICCW, we plan to build a reusable bottle that can give proper filtration solution while on go, so that people like truck drivers, bus drivers does not have to drink dirty water from nearby tap solutions and can avail proper filtered water. So basically, we plan to complete our final product with the help of acceleration award, and therefore we are aiming for the same award. Thank you.
Thank you very much, guys. Very nice. So, on to the questions from the jury. And I see Peter, he has figured out how to do the emoji now.
Yes, I have. Thank you very much for a very enthusiastic, great video and pitch. This is, of course, a very, very important achievement if you can solve this, not only for travelers, but I think for the world. When I read your material, I'm kind of getting the impression that you are primarily talking about suspended solids, and you also write something about heavy metals as the type of contaminants you want to remove. Did you think about microbial contamination? Because that's typically what creates immediate health problems when drinking contaminated water.
So can you please explain again? Can you talk? So actually the voice was not clear.
Oh, I'm sorry. It's about the pollution that you want, or the contamination you want to remove. I think you talk about suspended solids, and in your blog you also write heavy metals. But what about, say, microbial contaminants like protozoas being excreted, or things that are emitted from the human body when people are ill?
So actually for the bacteria and viruses, so actually from UF that has a pore size of 0.1 micron, so it removes the bacteria contents. And for viruses, we are planning to actually test it with our UV. That is, it is a very small UV LED that has a wavelength of around 275 nanometers. So it can be powered to our cell phones, because the power that it actually consumes is around 100 milliamps and 5 to 6 volts. So that can be powered to our phone. So that's how we plan to eliminate bacteria and viruses that will be present in the water.
Thank you. Good clarification.
Yes, and then I think we'll go on to NITI, who has raised her hand.
Hello again. Thanks for an excellent pitch again, and many congratulations on the good work. I have two things to ask. Can you tell us about what is the weight of the you are proposing a bottle structure, so what is the weight of the current model, and can you share about capacity and reusability, etc. of the product.
So as per our design and material selection, the whole bottle, the weight of the whole bottle will be approx 500 to 600 grams, just like our insulated bottle, metal insulated bottles. And the capacity of a bottle is around 1 liters. So it will be easy to carry and commute.
Thanks for the answer.
Okay, then I think we can take one quick question from Linda.
Yeah, great presentation and pitch. On your blog post, you also write your target customer segment. So have you already talked to some customers and did some testing? Because I see you already developed a prototype, and what was their feedback?
Yeah, so actually we talked with truck drivers and cab drivers like Ola and Uber one. So actually for truck drivers, the Kitab Singh, he was the actually truck driver. He said that while commuting from from one location to another, he will be traveling for 1 night or 2 nights. And during traveling, he does not get any proper source for filtered water because it is not. He actually does not earn that much that he can buy every time water bottle whenever he wants. So therefore, he drinks directly from whatever tap source that is present in the small restaurants and all. Due to which, what happens is he actually contact with waterborne diseases, and most between 4 to 5 months, on an average, he feels sick due to diarrhea and cholera, and because of that, he loses certain days pay. So he actually said that if a low cost product is there in order to avail this filtered water, it will help him a lot, as well as it will help him to earn a lot more money. And for the cab drivers, so actually in Lakshmana, he was the cab driver. So I was traveling from Chennai station to my location. So he actually bought a bottle during our travels, during the journey. So it was 20 to 30 kilometers. So when I asked him why you're buying this bottle, you can directly fetch the water from the tap that is there in bus stands. He said that no, actually I cannot touch that water, and because of that I have to spend this money. And he also said that he cannot actually he uses the money whatever he gets from what can I say is from the tips. He actually gets buys the water from the tips whatever he get from the customers. So if a solution is there, with does not he does not have to pay every time, it will be very beneficial for him. So that's what we plan to actually connect our product with our customers.
Thank you very much. I think that's it for the questions we have time for. And we'll be moving on to the next pitch with the Danish team, which has the members Pratik Iswar, Matthias Prajal, Sanel, and Harsh Varshan. So I'm gonna start the video, and then you guys should get ready for your live pitch after.
Have you ever experienced water shortage at home even after paying the water bills on time? Have you ever thought about why even after a month of monsoon and heavy floods you see a situation of water crisis in India? These scenarios are too common for urban households in India. While industries and affluent families extract umpteen groundwater as per their requirements, the potential rainwater runs off the ground into the drains, causing blockage and subsequent floods. Urban households tend to either extract groundwater or buy it through the municipal pipelines. Rainwater harvesting is never seen as a viable return on investment product. Only 8% of the rainwater is harvested in India, while it receives around 3000 millimeter of average annual rainfall. The groundwater level is declining at the rate of more than 50%, while we see the rainwater slip down the drain. To solve this issue, we at Sparnir have devised a cheap, reliable, and modular inverted umbrella prototype that collects rainwater, minimally filters it, and fills the tank set up on the rooftop of an urban household. The product has a high surface area and runoff coefficient, which collects 450 liters water on an average rainy day in competition to the 550 liter daily water consumption of a family of 4. The umbrella is fitted to the tank with a PVC filter pipe and is compatible with any usual water tank. The whole umbrella is supported by carabiners and incorporate a quick assembling process. The device is easy to fit on an existing tank and helps the customer save approximately 130 crores per season. The device not only harvests rainwater but also monitors the water and pH level in the tank. This helps in two ways. The data collected helps the water department to monitor rainfall quality, while the household gets regular information about the water in hand and ideal use cases for the same. Getting detailed rainfall data for the city is exceedingly difficult, given the costly equipment which needs to be set up at multiple locations. Our product helps do this easily and easily. Not only this, with the water data you get from the tank, the households can make judicious usage of water, preventing it from running out due to unnecessary usage.
Our product costs 590 crores, while commercial harvesting systems cost around 2,700 crores. The product gives a payback period of 4 years. Sparney earns money by selling the product to urban households for a marginal profit of 20%. Shipping the product needed us to survey more than 50 urban households. It helped us get the data about daily consumption, tank size, and water costs. It was motivating that 74% of the households agreed to install such a system, while the rest were unsure about the deal. One important aspect of this product is that it has a huge market of urban households in India to cater to. If we start from a pilot project in Mumbai and scale it gradually to other parts of India, we can achieve a huge available market. Additionally, given that the product fits to any type of tank, it can be scaled globally as well. The project took suitable time to develop with a team of 6 at Denmark Technical University.
The project is being supported by Indian government organizations like the Atal Innovation Mission AIM and the National Institution for Transforming India NITI. The Next Generation Water Action NGWA provided us with a great platform to get mentorship and support for our project idea. Working as a part of the course of entrepreneurship in DBU Skylab, we received traction from the Indian ambassadors to Denmark regarding the project. All these support pillars stand as a foundation for our project to be built as an established company. Thank you.
Very nice, guys. So, ready for the live pitch whenever you are.
Thank you for your attention. As you would have noted, we are Sparnir, who are trying to solve the water management problem in India. Spar in Danish means to save, while Neer in Hindi means water. Our cheap, reliable, and a modular solution has a large market needs in India, as well as a huge scale to achieve. So join us in not letting life slip down the drain while we strive to form an established company. Thank you.
Very nice and on point. So, does the jury have any questions? And Peter is fast as usual.
Thank you very much. Very nice video and pitch. I do have a very technical question, and it's about the amount of water that you can collect. If I understand it correctly, you have this umbrella on top of a water tank directly. How large is that umbrella?
So basically, the umbrella has a surface area of around 8.5 meters squares. And based on the amount of rainfall we get in Mumbai during the rainy season and the runoff coefficient, so we calculated it to be around 450 liters per season. That's the amount we would be collecting.
It is the projected surface area, the top surface area, projected.
Okay, so that is somewhat larger than the impression giving on the images that you provide. Because there I get the impression of I don't know, 1 square meter or something like that, directly on top of a tank.
Yeah, so the tank is it is a general tank which we find in any urban household in India. So we have tried to that is the surface. If we calculate the surface area for that, then it is comparable, the 8.5 meter square. is comparable to the area to that tank.
So that's a very large tank then in a household.
Yes, yes.
Okay.
In the video, this tank was shown.
Like in general, all these houses have the tanks which have a capacity of around 1,000 to 2,000 liters, so they are quite huge in size.
Yeah.
Okay. These are crucial details. I think you should add them somehow to be sure that the idea is viable, because I could not check that from the material I got. But otherwise, I think it's really nice. Thank you.
Thank you.
Yes, very nice. Put a banana for scale. So, and I see there is a question already from Divya.
Hi. So I just wanted to confirm, apart from pH, is there any other water quality parameter you are targeting?
So basically, the app tests water level and the pH level. We didn't focus on calculating the water purity levels, because in general, as you know, in all Indian households, we have already a water filter installed, which is doing that filtration process. So our mainly project idea was to just not let this rainwater be harvested, because we found from some data that only 8% of rainwater which pours in India is being harvested, and the rest just slips down. So our main focus was on to utilize this rainwater.
Thank you. We have time for one more question. Oh, I see Linda and Peter, but at the same time, but let Linda take this round.
Thank you very much for the presentation, and very great idea. I was just curious, what is your immediate next step, and what would you need to proceed with your project?
Yeah, so currently we have got a letter of intent from a like 15 household complex in India. So we will be having a pilot project there, and like subsequently we'll be scaling it first in Mumbai city, and then to other urban households in India, urban cities where we get ample amount of rainfall. So as you can see from the market size, we will be trying to tap into multiple cities and expand it later.
And you're going to be based in Denmark, or will some of the team be actually in India?
In India, it will be based in India. The product, while the umbrella is the design is such that it can be scaled globally as well, but we'll be trying to focus in India first, and then exploring it in the long run.
Thank you.
Well, thank you guys for your answers, and Jury for your questions. We'll now be moving on to the last pitch of today with Team India 3, with Karthik, Subha, and Pavani. And I'm gonna run the last video, and group can get ready for the live pitch.
Hi, this is Karthik as lead from Team EIN3 and my title is Smart Water Quality Monitoring System. My teammates are Subha Reddy and Pavani. We all belongs to Osmania University, Hyderabad, India. My mentor is Professor L. Nirmala Devi. My work details is, water is essence of life. According to British poet W.H. Auden once noted, thousands have lived without love, not one without water. Yet while we all know water is crucial for life, we trash it anyway. As a result, the drinking water sources, both from surface and groundwater bodies, are becoming increasingly polluted, demanding expensive and extensive treatment before use. Studies conducted by the United States Environmental Protection Agency, USPA, have shown that water parameters are affected by contaminants in special ways and can be detected and monitored using appropriate water quality sensors. As per WHO report, contamination of water is the major cause for waterborne diseases. In order to detect the water contaminants, Electrochemical and optical sensors are needed to measure physical and chemical properties of water quality. The water parameters which are the focus of this project are pH, temperature, ORP, and turbidity. These physico-chemical parameters can be used to detect certain water contaminations. The pH is of major importance in determining the corrosivity of water. pH is a unit of measure which describes the degree of acidity or alkalinity of a solution. The pH of most raw water lies within the range of 6.5 to 8.5. The sample of water with a low pH less than 6.5 could be acidic, soft and corrosive. Drinking water with a pH 8.5 could indicate that the water is hard. Turbidity is the cloudiness or haziness of a fluid mechanism, and is quantified by the intensity of light scattered by particles suspended in the medium. Turbidity is quantified by the nephelometric turbidity unit, NTU. Governments have set standards on the allowable turbidity in drinking water. The WHO establishes that the turbidity of drinking water should not be more than 5 NTU, and should ideally be below 1 NTU. ORP, oxidation reduction potential, is a measure of the ability of oxidation and reduction of aqueous solution, characterization of oxidizing or reducing the relative degree. Normal tap water has an ORP value of between 200 to 400 millivolts. ORP is a non-standardized water quality indicator, but WHO recommends that the ORP of drinking water should not exceed 60 millivolts. The temperature measurement of the water is required for compensation, as these parameters can have an effect on other parameters. Hardware description of the model is: we used MSP432 from TI and SIMCOM 808 for GPRS service. Inbuilt 14-bit ADC of MSP432 collects the data from sensors. GPRS module connects the embedded device to Internet. The UART interface which connects the GPRS module and the MSP432. Signal conditioning converts unstabilized voltage to stabilized voltage and then connected to ADC pins. The development environment for the system software is Code Composer Studio. In monitoring section, or dashboard, user can log in to the portal and able to select deployment region through Google Maps, if the device is established to connected in that location. The user can visualize the selected deployment region sensor readings in real time, can identify alerts and warnings of sensors. Alerts are occurred when sensors are not connected to the microcontroller. The user will get notified. Warnings are occurred when water parameters go beyond the defined level, then the user will get notified. A short message service is also provided in this system for registered user when there is a deviation of water quality parameters from predefined set of standard values. The system is protected from environment conditions by using selective laser sintering based 3D printing mentioned as white box.
Ready for the live pitch whenever you are.
Yep. Good evening.
We are not hearing anything.
Yeah, it is audible to me. Video, it's not.
Yeah, it's okay without the video. If you can start the live pitch.
So the WHO reports 2 million people are suffering from the water contaminated. And we developed it provides the support for good decision making in prevention of water contaminants with the help of alerts and warnings. And our system is capable for good detection accuracy and low deployment operation cost. And my equipment cost is around 35,000 rupees. It is mostly affordable for the different locations. We are mainly focusing on the slum area locations where the water is mostly contaminated. We want to have the awareness to the public regarding the what level of water it is contaminated, so that the public can easily access through the dashboard, or you can have the alerts and warnings to the particular water contaminated, so that they can avoid the waterborne diseases surrounding the slum areas.
Thank you, guys. It was a bit low, the volume, but I could at least hear it. Hope the rest of the audience could as well. So again, thank you very much for the pitch. And now it is time for Peter to start the questioning.
Thank you very much. I actually hit the wrong hand. I just wanted to clap, but I can start. I can start also. Thank you for a very interesting pitch. So how far are you? You write that the proposed system is successfully tested in different water environments, and then you mention some water quality parameters. How far are you in actually testing this? I'm sorry, I cannot hear anything. It seems we lost the connection.
We'll just give it a few seconds more. Maybe try muting and unmuting again.
Hello?
Oh, that did not help. Do a quick refresh of the browser tab. We'll pause the Q&A timer. Meanwhile.
Hello?
Oh, now it's there.
Okay, thank you very much. Yeah, we deployed in the different locations in the university, and we have tested the water contaminants in our deployed tanks. And we recently have the collaboration with the Water Pollution Board and the Municipality Board in Hyderabad. We deployed at the different locations surrounding the Musi River, and we gave some awareness related to the contamination of water in the near to that river, contaminated river, like a pond. It is available in between the city. And the users can easily access the data, and they can understand what level of contamination is there in their surrounding areas.
I think this sounds as a great idea. It's also an idea that is beginning to become more and more discussed internationally, because we completely lack data on environmental status, and also we lack open data that is accessible to the public. So I think you are targeting a very interesting market here. Good luck with it. I think it's really worthwhile to try it. Yep.
Thank you very much.
Thank you. And then I see we have a question from Davia.
Kartik, so just
Yeah,
wanted
yes.
to know, have you done any cost analysis for that sensor?
Sorry?
Have you done any cost analysis for that sensor?
I'm getting the double sound, some disturbance in the noise.
Am I audible now?
Yeah, maybe you can write it in the chat. I heard SWOT analysis, but
cost analysis.
Cost analysis.
Cost analysis.
Cost analysis, it is taking around 35,000 rupees. My sensors, it costed around 15,000 rupees, and the solar and batteries, it has taken around 10,000 rupees. And my prototype regarding the 3D printing, it has taken around 5,000 rupees. For the protecting the sensors and the modules, it has taken 5,000. I tested in the different environmental conditions. It's successfully tested because of the protection of the 3D printing device. And the remaining total cost, it is taking around 35,000 rupees.
Thank you. And I think that was the questions we had time for now. And I again want to remind you guys that it's possible to stay after and ask more questions to the groups. But now I think we're going to have some closing remarks by Penan, now that we have fixed the connectivity issues he was having before. So welcome aboard, Penan.
Thanks. First,
Sorry, my connection was really bad and I could not connect. Thanks a lot for having me, and especially this time compared to last time, I was personally involved in more than 3 or 4 projects. I could go and see them in person and give comments. And it is very good to see, as Peter was saying, very new ideas and much needed ideas coming up from young minds with the support of ICDK, NITI Aayog, and DTU. So it's a nice platform that has been established. Some technicalities maybe need to be ironed out in the coming season, which at least we have given a stepping stone from which they could start looking at these directions and a contact database that they could always come back to us for questions and comments. The most important thing is both water is becoming a global problem, and it's good to see that multiple people are focusing on India's problem and Indian teams are focusing on other problems. But the context is same, just saving water in an unexpected climate change scenario, and with ever-growing demands for water. So it's both the supply side and demand side, both they're looking at. In one aspect, we see how they could reuse, recycle the water using smart filters, mobile apps, and connecting the data to the people, which is again your demand side and supply side management. And then the other side, we are looking at good ways to assess the quality of water before even using it for a particular purpose. It is very nice to see how they started and how they ended, because while starting it was like baby steps, but then they were just taken up on board with all the team members in DTU and NITI Aayog and ICDK, and was so happy to be part of it. I look forward for seeing these products in the market and me buying itself one day. Thank you.
Thank you very much, Pinan, and a big congratulations to all the teams for what you have been presenting today. We're not only trying to push the limits on how you collaborate internationally with a number of different partners along the way, but I'm sure we're also pushing a lot of you in the way that we would like you to try and communicate your solutions through the video pitches and the blog posts. For us, it's very much about being open about our solutions at an early stage. We can only benefit and leverage on creating open innovations where we are also able to connect you with our ecosystem here in Denmark, but also internationally, trying to promote and accelerate your solutions as well. As I indicated in the beginning, today is not the end. It's an important milestone for all of you. I know that the jury is going to have a tough time in terms of scoring and understanding who we are going to grant the Acceleration Award, but also who we're inviting to pitch live at our final session next week. It's also an opportunity for you to connect and provide additional sparring to the teams. So there is the opportunity immediately after to join one of the breakout sessions that we have organized into each of the student teams where you can connect and say hi to them. There is also a tab below the live stream on the website where you can offer your mentorship to one of the specific student teams or several of the student teams. That is a way where you can also connect with the team going beyond the Next Generation Water Action Initiative. So I would encourage you also there to indicate your interest to work further and be connected with the teams that have been presenting today. You have also all been invited to the multi-hub finals taking place on Thursday. So I would encourage those of you that haven't already signed up to sign up. It's going to be an exciting event. Also for those of you that are not going to pitch live, you're going to be able to access and meet in person a lot of the people that have been involved along the way in this journey. Thank you very much for the jury to give comments. I know that there is also comments in the evaluation sheet as well. I want to say thank you very much for a really good session across the world, dealing with the technicalities along the way. I think we all did very well, so thank you as well for being good sports in that. And see all of you next Thursday in the final. So stay tuned. Now there are the breakout sessions, and looking forward to see you on Thursday. Thanks a lot to all of you.